All right, so today we're going to be talking about polynomials, starting chapter 7. And we're going to be doing properties of exponents. So don't forget to put the page number for what your notebook is on. I'm going to be on page 42. Alright, so we're doing properties of exponents. So we're going to start with the product rule. Which just states, when multiplying exponents with the same base, keep the base and add the powers. So if we have a to the n times a to the m, that will equal a to the n plus m. So basically when I multiply variables, I have to add the exponents. So for some examples, if I have x squared y cubed times y to the fifth x to the fourth, to figure this out, I combine my x's together by adding my exponents. So I'll take the 2 plus the 4. So 2 plus 4 gives me 6. And then I'll combine the y's together. So I have to take 3 plus 5, which would give me 8. Now if I have more than two variables, so say that I have a times b squared times c, and I'm multiplying this times b to the fourth c cubed, I combine the same variables. So since I have an a here and there's no a here, a will just stay the same, just stays a. B's, I combine those, so I have to take 2 plus 4. So that would give me 6. And then for the C's, I would have to combine those. So I take 1 plus 3, which would give me 4. So our next rule is the quotient rule. And it says, when dividing exponents with the same base, keep the base and subtract the powers. So when we multiplied, we added. This time when we divide, so if I have a to the m over a to the n, since these are both a's, I subtract my exponents. So I get a to the m minus n. So if I have x cubed y squared over xy cubed, I subtract. So I take my x's, and remember, since there's nothing written here, I understand there to be a 1. So I will subtract 3 minus 1. So that would give me x squared. And then 2 minus 3 would give me a negative 1. And we'll come back to this one after we deal with negative exponents. So let's just go ahead and do negative exponents next. So the negative exponent rule tells us that a negative exponent causes the number to be rewritten as the reciprocal of the original number, and the exponent becomes positive. So basically, whenever I have a negative exponent, I just have to flip it over and make the exponent positive. So if it was a whole number, it would become a fraction. So for instance, if I had x to the negative 3, y to the negative 2, I would have to flip both of these because they're both negative. So they both have to move to the denominator of the fraction and get y cubed, x cubed and y squared in the denominator. Now, if I had x cubed over y to the negative fourth, since this is in the denominator, when I flip it over, it moves to the numerator, and the x cubed, since this is already positive, it stays in the numerator. So I'll move this y to the negative fourth up to the numerator, and then I can write this over 1 because there would just be this 1 would just be left in the denominator, or I could leave it as x cubed y to the fourth. So going back up to this problem that we had left up here, since I had a negative exponent, I can't leave my answer with negative exponents, so this one is the one that has to move to the denominator. The x squared is already positive, so it stays in the numerator right where it's at. So I move the y to the denominator, so it becomes x squared over y to the first. You could also just write this as x squared over y. You don't have to write this one, but it's not wrong if you do. All right, so next we're going to do our power rules, which just states that the power of a power, so to raise a power to a power, we multiply the exponents. So if I have a to the n to the m, I just have to multiply these exponents together. So n times m would be a to the nm. So say I had x squared to the fourth. So to simplify this, I would just have to multiply 2 times 4. So I get, x to the 8th. And then next it says power of a product. So each base is raised to the power. So if I have 2 things in the parentheses, so say I have x squared y cubed, and I'm taking this to the 5th power, I have to take both of these, since they're inside, to the 5th power. So that means I'm multiplying both of these exponents times that 5. So 2 times 5 would give me 10, so I get x to the 10th. And then 3 times 5 would give me 15, so I would get y to the 15th. Now, if I have, say, 2x to the 4th over y squared, and this is all squared, I have to raise everything in here. So this 2 really has an exponent as well. Remember, just because it's not written in there, we can write that 1 in there. And then we can multiply all of the exponents then times this 2. So 1 times 2 would give me a 2, so I get 2 squared. And then 4 times 2 would give me 8, so I get x to the 8th. And then in the denominator, I get 2 times 2, which would give me y to the 4th. Now, unfortunately, I can't leave my answer this way because I can simplify 2 squared. So 2 squared gives me 4. So my answer would give me 4x to the 8th all over y to the 4th. All right, so the last rule that we have to go over is the 0 exponent rule. And that just tells us that any number raised to the 0 power is equal to 1. So if I have a to the 0 power, that would equal 1. X to the 0 power would equal 1. If I have negative y to the 0 power, this would equal 1. But if I had a negative y to the 0 power this way, our properties of our order of operations tells us that we have to do the exponents before we do the negative. So we would have to take y to the 0, which would be 1, and that negative would still be there. So make sure you're paying attention. Is the negative inside the parentheses with the variable that's raised to the power, or is it not? Because here I have to do the variable raised to the power first before I put the negative on. Here I have the negative on first, so that means this whole thing turns to 1. All right, so that's it. We will hand out homework next, and you may work on homework.